Here are 50 most commonly asked interview questions for Google Cloud Dataflow, along with detailed and informative answers for interviews. 1. What is Google Cloud Dataflow? Answer: Google Cloud Dataflow is a fully managed, cloud-based service for stream and batch processing of large datasets. It provides a unified programming model and an execution environment for data processing pipelines. Dataflow is designed to be highly scalable, capable of handling massive datasets and complex data transformations in real time. It leverages Apache Beam SDK for defining data pipelines, which can be executed on various runtime environments. Dataflow's key capabilities include real-time analytics, ETL processes, and data integration workflows, making it a versatile tool for modern data engineering needs. 2. Explain the key features of Google Cloud Dataflow. Answer: Google Cloud Dataflow comes with several key features like A. Unified programming model. Uses Apache Beam to support both stream-like real-time and batch processing within the same framework, allowing developers to write flexible and reusable data pipelines. B. Autoscaling. Automatically scales compute resources up or down based on the workload, ensuring efficient resource utilization and cost management. C. Integration. Seamlessly integrates with other Google Cloud services such as BigQuery, Cloud Storage, Bigtable, and Pub or Sub, enhancing the ecosystem for comprehensive data solutions. D. Fully managed service. Handles infrastructure management, such as provisioning and maintaining resources, so developers can focus on building and optimizing pipelines rather than managing servers. E. Real-time processing. Capable of processing streaming data with low latency, enabling real-time analytics and quick decision-making. 3. What is Apache Beam and how does it relate to Google Cloud Dataflow? Answer: Apache Beam is an open-source, unified programming model for defining and executing data processing pipelines. It abstracts the complexities of different processing engines by providing a single API to create pipelines, which can be run on multiple runners such as Google Cloud Dataflow, Apache Flink, and Apache Spark. Google Cloud Dataflow acts as a runner for Apache Beam, executing Beam pipelines in a scalable and managed cloud environment. This integration allows developers to leverage Beam's powerful model for both batch and streaming data while utilizing Dataflow's robust execution capabilities. 4. What are PCollections in Google Cloud Dataflow? Answer: PCollections parallel collections are the core data structures in Apache Beam and Google Cloud Dataflow. They represent datasets within a pipeline and can be either bounded or unbounded. A. Bounded PCollections correspond to finite datasets typically used in batch processing. B. Unbounded PCollections correspond to infinite datasets typically used in stream processing. PCollections are used to apply transformations, pass data between different stages of a pipeline, and handle complex data workflows in a parallelized manner. 5. Describe the different types of transforms available in Google Cloud Dataflow. Answer: transforms are operations applied to PCollections to process data. Key types include A. Par-do, a parallel do operation that applies a user-defined function to each element in the input PCollection, producing 0 or more output elements per input element. B. Group by key, groups elements of a PCollection by a specified key, useful for aggregating data by key. C. Co-group by key, merges two or more PCollections by their keys, combining data from different sources into a single PCollection. D. Combine, aggregates data across a PCollection, eyeing a user-defined function to reduce the dataset. Examples include summing values or computing averages. E. Flat, merges multiple PCollections into a single PCollection. F. Partition, divides a PCollection into multiple PCollections based on a user-defined partitioning function. 6. Explain the concept of windowing in Dataflow. Answer: window is a mechanism in Dataflow to group elements of an unbounded PCollection like streaming data into finite chunks, enabling operations like aggregation over specific time periods. Types of windowing include: A. Fixed-time windows, divide data into non-overlapping, fixed-size intervals, for example, every 5 minutes. B. Sliding windows, create overlapping windows that slide over time, capturing data in overlapping intervals, for example, every 1 minute, sliding windows of 5 minutes duration. C. Session windows, group events that occur within a specified gap duration, useful for capturing periods of activity followed by inactivity. D. Global windows, all data belongs to a single, infinite window, typically used when windowing is not required or for batch processing. 7. What is watermark in Dataflow? Answer: a watermark is a timestamp indicator that Dataflow uses to track the progress of event time within a streaming pipeline. It estimates the point in event time up to which all data is expected to have been received. Watermarks help determine when to trigger windowed computations and manage late data. A watermark ensures that results are produced timely while balancing the completeness and accuracy of the data processing. 8. How does Google Cloud Dataflow handle late data? Answer: Dataflow allows for the handling of late data by specifying an allowed lateness period in windowing. This is done through the withAllowedLateness method in Apache Beam. Dataflow uses triggers to control when results are emitted for each window. The combination of allowed lateness and triggers allows late arriving data to be included in the computations for a window even after the watermark has advanced. This approach ensures that the pipeline can handle real-world scenarios where data can arrive out of order or be delayed. 9. What are triggers in Dataflow? Answer: triggers control when the results for a window are produced based on certain conditions. Different types of triggers include: A. Event time trigger, based on the progress of event time as indicated by the watermark. B. Processing time trigger, based on the actual time of processing rather than event time. C. Element count trigger, fires after a specified number of elements have been processed in a window. D. Composite triggers, combine multiple trigger conditions to create complex triggering scenarios. For example, firing on event time and re-firing after a certain processing time if additional late data arrives. Triggers provide flexibility in managing how and when results are output from a pipeline, enabling sophisticated handling of different data arrival patterns and processing requirements. 10. Explain the difference between batch and stream processing in Dataflow. Answer: batch processing involves processing a finite, bounded dataset. The job processes all the data available at the start and terminates after processing. It is suitable for tasks like ETL, where all data can be collected before processing. Stream processing handles unbounded datasets where data continuously arrives over time. The job runs indefinitely, processing data in real time as it arrives. Stream processing is suitable for applications that require real-time analytics, event detection, and continuous data transformation. The main difference lies in the nature of the dataset, like bounded versus unbounded, and the operational model, like finite versus continuous. 11. What is the role of pub or sub in a Dataflow pipeline? Answer: Google Cloud Pub or Sub is a messaging service for real-time message ingestion and delivery. In a Dataflow pipeline, pub or sub can serve as: A. Source, reading streaming data in real time from pub or subtopics into a Dataflow pipeline for processing. B. Sink, writing process data from a Dataflow pipeline back to pub or subtopics for further consumption by other applications or services. Pub or sub enables decoupled communication between different components of a data architecture, facilitating scalable and reliable data ingestion and distribution. 12. How do you handle schema changes in Dataflow pipelines? Answer: Handling schema changes in Dataflow pipelines involves several strategies like A. Schema versioning, maintaining multiple versions of the schema to ensure backward and forward compatibility. B. Dataflow schema transformations, utilizing Dataflow schema. Support to adapt to different schema versions by applying transformation logic to map fields from one schema to another. C. Flexible pipelines, designing pipelines to accommodate optional fields or variations in the schema, allowing them to process records even if they don't conform strictly to a single schema version. These strategies ensure that schema changes do not disrupt the pipeline's operation and that data can continue to be processed accurately. 13. What is a side input in Dataflow? Answer. A side input is a supplementary dataset that can be used by a Pardue transform in addition to the main input PCollection. Side inputs are typically used for A. Broadcast data, data that is needed by all workers during the processing, such as lookup tables or configuration settings. B. Static datasets, smaller datasets that can be accessed efficiently by each worker without being part of the main data flow. Side inputs enable more complex data processing patterns where additional, smaller datasets need to be joined or used in conjunction with the main data being processed. 14. Describe the process of debugging a Dataflow pipeline. Answer. Debugging a Dataflow pipeline involves several techniques like A. Logging, adding logging statements within transforms to output debug information at various stages of the pipeline. B. Pipeline graph visualization, using the Dataflow monitoring UI to visualize the pipeline structure, execution stages, and data flow, helping identify bottlenecks or errors. C. Stackdriver monitoring and logging, bridging Google Cloud Stackdriver tools to monitor resource usage, performance metrics, and access detailed logs for troubleshooting. D. Unit testing, running unit tests for individual transforms, using the Apache Beam testing framework to ensure correctness of the logic before deploying to production. These approaches help in identifying and resolving issues within the pipeline, ensuring smooth and efficient data processing. 15. How does Dataflow ensure data consistency and reliability? Answer. Dataflow ensures data consistency and reliability through several mechanisms like A. Checkpointing, periodically saving the state of the pipeline's processing, enabling recovery and continuation from the last checkpoint in case of failures. B. Exactly once processing, implementing mechanisms to ensure each record is processed exactly once, avoiding duplicate processing and ensuring data accuracy. C. Fault tolerance, automatically recovering from worker failures by redistributing work and reprocessing data as necessary. These features ensure that Dataflow pipelines maintain data integrity and can handle failures gracefully, providing reliable data processing. 16. What is the difference between fixed and sliding windows? Answer. A. Fixed windows divide the data into non-overlapping, fixed-size intervals. For example, dividing a stream of data into 5-minute windows. Each window captures events occurring within that specific interval. B. Sliding windows create overlapping windows that slide over time. For example, a 5-minute window that slides every 1 minute. Each window captures events from overlapping intervals, allowing more granular analysis and aggregation over time. Fixed windows are simpler and useful for periodic reporting, while sliding windows provide more detailed and overlapping insights, useful for detecting trends and patterns. 17. Can you explain the concept of session windows? Answer. Session windows group events that occur within a certain gap duration, making them ideal for capturing periods of activity followed by inactivity. A session window is defined by a gap duration parameter, which specifies the maximum allowed gap between consecutive events to be considered part of the same session. If no new data arrives within this gap, the window is closed, and a new session window starts with the next arriving data. Session windows are particularly useful for use cases like user activity tracking, where you want to group events based on user sessions. 18. What is the global window in Dataflow? Answer: the global window is a windowing strategy where all data elements are considered to be part of a single, infinite window. This is typically used in batch processing scenarios where windowing is not needed, and the entire dataset is processed as one unit. In streaming scenarios, the global window might be used when continuous aggregation or processing across the entire data stream is required without breaking it into smaller windows. 19. How do you perform stateful processing in Dataflow? Answer: stateful processing in Dataflow allows maintaining and accessing state information across multiple elements in a PCollection. This can be achieved using by a. Stateful PAR-do, using Apache Beam's state and timer APIs within a PAR-do transform to maintain state across invocations. User-defined state can be used to keep track of information between elements, such as counters or running aggregates. b. Timers, scheduling future processing events based on state. Timers can be set to fire at specific event times or processing times, enabling complex event-driven processing and state management. Stateful processing is useful for scenarios where operations depend on previously processed data or require maintaining context across multiple elements. 20. What are the primary considerations for optimizing a Dataflow pipeline? Answer: optimizing a Dataflow pipeline involves several considerations like a. Efficient transform design, minimizing the use of resource-intensive transforms, and combining operations where possible to reduce overhead. b. Resource management, properly configuring machine types and autoscaling options to ensure efficient resource utilization without over-provisioning. c. Data shuffling, reducing the amount of data shuffled between workers, which can be a major performance bottleneck. Using techniques like combiner functions can help minimize shuffling. d. Parallelism, maximizing parallelism by using appropriate partitioning and windowing strategies to ensure that data is evenly distributed across workers. e. Monitoring and tuning, continuously monitoring the pipeline's performance using tools like Stackdriver, and making adjustments to resource allocation, windowing strategies, and other parameters based on observed performance. 21. How do you monitor the performance of a Dataflow job? Answer: monitoring performance of a Dataflow job involves a. Dataflow monitoring interface, using the visual dashboard provided by Dataflow to monitor the status, execution progress, and performance of the pipeline. b. Stackdriver monitoring, bridging detailed metrics and logs provided by Stackdriver to monitor resource usage, latency, throughput, and other performance indicators. c. Custom metrics, implementing custom metrics within the pipeline to track specific application-level performance metrics and KPIs. d. Alerts and notifications, setting up alerts and notifications for key performance thresholds to proactively manage and resolve issues. Monitoring helps ensure that the pipeline runs efficiently and meets performance SLAs. 22. What is the role of autoscaling in Dataflow? Answer: autoscaling in Dataflow automatically adjusts the number of worker instances based on the workload. This ensures optimal resource utilization by scaling up during periods of high demand and scaling down during periods of low demand. Autoscaling helps manage costs by only using the necessary resources to meet the pipeline's processing requirements. It also ensures that the pipeline can handle varying loads without manual intervention, providing a seamless and efficient data processing experience. 23. How do you handle data skew in Dataflow? Answer: handling data skew involves several strategies like a. Partitioning, ensuring even distribution of data across workers. By using appropriate partitioning keys and strategies to avoid hotspots. B. Combining operations, using combiners to perform partial aggregations and reduce the amount of data shuffled between workers, minimizing the impact of skewed data. C. Hotkey mitigation, identifying hotkeys like keys with disproportionate amounts of data and distributing them more evenly, possibly by splitting or replicating data associated with hotkeys. D. Custom load balancing, implementing custom load balancing logic within the pipeline to dynamically distribute data more evenly. These strategies help maintain balanced workloads across workers, improving overall pipeline performance. 24. What are some common use cases for Google Cloud Dataflow? Answer. Common use cases for Google Cloud Dataflow include A. Real-time analytics, processing streaming data from sources like IoT devices, social media feeds, or clickstreams to provide real-time insights and dashboards. B. ETL pipelines, extracting data from various sources, transforming it into a desired format, and loading it into data warehouses like BigQuery for analysis. C. Event processing, handling and responding to events in real time, such as fraud detection, anomaly detection, and alerting systems. D. Batch processing, large-scale data processing tasks such as daily data aggregations, reporting, and data migrations. E. Machine learning pipelines, data preprocessing, feature extraction, and transformation for machine learning, model training, and inference. These use cases demonstrate Dataflow's versatility in handling various data processing scenarios. 25. Explain the concept of a composite transform in Dataflow. Answer. A composite transform in Dataflow is a higher-level transform that combines multiple lower-level transforms into a single logical operation. This is useful for encapsulating common processing patterns and simplifying the pipeline code. For example, composite transform might include reading data from a source, performing several transformations, and then writing the processed data to a sink. Composite transforms promote code reusability, modularity, and readability by abstracting complex processing logic into manageable units. 26. How do you configure a Dataflow job for fault tolerance? Answer. Configuring a Dataflow job for fault tolerance involves A. Checkpointing, enabling periodic checkpointing to save the state of the pipeline's processing, allowing for recovery from the last checkpoint in case of failures. B. Retries, configuring retry policies for failed operations to ensure transient errors are retried automatically. C. Backup and recovery, implementing backup and recovery strategies for critical data, ensuring data integrity in case of catastrophic failures. D. Monitoring and alerts, setting up monitoring and alerts to detect and respond to failures promptly, minimizing downtime and data loss. These configurations ensure that the Dataflow pipeline can recover from failures and maintain data consistency and reliability. 27. What is a DoFn in Apache Beam, and how is it used in Dataflow? Answer. A DoFn, short for do function, is a user-defined function in Apache Beam that specifies the processing logic for each element in a PCollection. It is used within the par_do transform to apply custom processing to each element. A DoFn includes methods for setup, processing elements, and teardown, allowing for complex data transformations and state management. In Dataflow, DoFn is used to implement the core processing logic of the pipeline, enabling a wide range of data processing tasks, from simple filtering to complex aggregations. 28. How does Google Cloud Dataflow support multi-language pipelines? Answer. Google Cloud Dataflow supports multi-language pipelines through Apache Beam's multi-language capabilities. This allows developers to write different parts of the pipeline in different programming languages such as Java, Python, and Go. Beam's portability framework facilitates communication between different language SDKs and execution environments. This enables the use of existing libraries and tools in various languages, promoting flexibility and collaboration among teams with diverse skill sets. 29. What are the common strategies for testing Dataflow pipelines? Answer: common strategies for testing Dataflow pipelines include A. Unit tests for individual transforms using Apache Beam's testing framework to ensure correctness of the logic. B. Integration testing, testing the complete pipeline with a small sample of data to verify end-to-end functionality. C. Mocking external services, using mock objects to simulate interactions with external services such as databases, message queues, and APIs. D. Performance testing, running performance tests to ensure the pipeline meets performance requirements under expected workloads. These strategies ensure that Dataflow pipelines are robust, reliable, and performant before being deployed to production. 30. Explain the concept of fan-out and fan-in Dataflow. Answer: fan-out refers to the process where a single input PCollection is split into multiple PCollections, often through transformations like par/do that produce multiple outputs. This allows for parallel processing of different aspects of the data. Fan-in refers to the process of combining multiple PCollections into a single PCollection, often using transformations like flatten or group by key. This allows for the aggregation and consolidation of data from different sources or processing paths. Fan-out and fan-in enable complex data workflows by allowing data to be processed in parallel and then combined as needed. 31. How do you manage data integrity in a Dataflow pipeline? Answer: managing data integrity in a Dataflow pipeline involves A. Schema enforcement, using schema validation to ensure data conforms to expected formats and structures. B. Data validation, implementing validation logic within the pipeline to check for data quality issues such as missing or invalid values. C. Idempotent operations, designing transformations to be idempotent, ensuring that repeated processing of the same data does not lead to inconsistencies. D. Error handling, implementing robust error handling to capture, log, and possibly correct errors in the data processing. These practices help maintain high data quality and ensure that the pipeline produces accurate and reliable results. 32. What are the advantages of using Google Cloud Dataflow over other data processing frameworks? Answer: advantages of using Google Cloud Dataflow include A. Fully managed service, eliminates the need for infrastructure management, allowing developers to focus on building and optimizing pipelines. B. Unified model, supports both batch and stream processing within the same framework, enabling flexible and reusable pipelines. C. Scalability, automatically scales resources based on workload, ensuring efficient resource utilization and cost management. D. Integration with Google Cloud ecosystem, seamlessly integrates with other Google Cloud services, providing a comprehensive solution for data processing, storage, and analysis. E. Real-time processing, capable of handling real-time data streams with low latency, enabling quick decision-making and responsive applications. These advantages make Dataflow a powerful and convenient choice for modern data processing needs. 33. What are some best practices for designing Dataflow pipelines? Answer: best practices for designing Dataflow pipelines include A. Modular design, breaking the pipeline into smaller, reusable components to promote maintainability and reusability. B. Efficient transformations, minimizing the use of expensive operations, and combining transformations where possible to reduce overhead. C. Proper windowing and triggers, using appropriate windowing and triggers to handle streaming data effectively and ensure timely results. D. Monitoring and logging, implementing comprehensive monitoring and logging to track pipeline performance and troubleshoot issues. E. Testing, writing thorough unit and integration tests to ensure pipeline correctness and reliability before deployment. These best practices help create efficient, reliable, and maintainable data processing pipelines. 34. How does Dataflow handle backpressure? Answer: Dataflow handles backpressure through a combination of techniques like A. Autoscaling, automatically scaling the number of worker instances to handle varying workloads and prevent bottlenecks. B. Dynamic work rebalancing, distributing work among workers to ensure balanced workloads and prevent individual workers from being overwhelmed. C. Buffering, using in-memory and on-disk buffering to manage temporary surges in data volume, ensuring smooth processing without data loss. D. Throttling, implementing throttling mechanisms to control the rate of data ingestion and processing, preventing overload of downstream components. These techniques ensure that the pipeline can handle varying data volumes and maintain steady processing rates. 35. Explain the concept of checkpointing and its importance in Dataflow. Answer: checkpointing. Dataflow is the process of periodically saving the state of the pipeline's processing. It allows the pipeline to recover and resume processing from the last checkpoint. In case of failures, ensuring data integrity and continuity. Checkpointing is important because it A. Enhances fault tolerance, enables recovery from worker failures without losing data or processing progress. B. Maintains consistency, ensures that intermediate processing states are preserved, allowing for accurate and consistent results. C. Supports stateful processing, facilitates the management of stateful transformations. By periodically saving and restoring state information, checkpointing is crucial for maintaining reliable and robust data processing pipelines, especially in long-running and stateful stream processing scenarios. 36. What are some common challenges when working with Google Cloud Dataflow? Answer: common challenges when working with Google Cloud Dataflow include A. Complexity. Designing and managing complex data pipelines can be challenging, especially for large-scale or stateful processing. B. Cost management. Optimizing resource usage to control costs while maintaining performance can be difficult. C. Data skew. Ensuring even distribution of data to avoid hotspots and performance bottlenecks requires careful planning. D. Schema evolution. Managing schema changes and ensuring compatibility across different stages of the pipeline can be complex. E. Debugging. Troubleshooting issues in distributed processing environments can be challenging due to the complexity of the execution environment and the need for comprehensive logging and monitoring. Addressing these challenges requires a combination of best practices, careful planning, and effective use of data flows, features, and tools. 37. How do you manage dependencies in a Dataflow pipeline? Answer: managing dependencies in a Dataflow pipeline involves A. Using dependency management tools, leveraging tools like Maven or Gradle to manage and resolve dependencies for Java-based pipelines. B. Specifying dependencies in code, including all necessary dependencies within the pipeline code to ensure they are available during pipeline execution. C. Testing dependencies, thoroughly testing the pipeline with all dependencies to ensure compatibility and functionality before deployment. D. Managing transitive dependencies, ensuring that all transitive dependencies are correctly resolved and do not cause conflicts or version issues. Proper dependency management ensures that the pipeline runs smoothly and without issues related to missing or incompatible dependencies. 38. How do you optimize resource usage in a Dataflow pipeline? Answer: optimizing resource usage in a Dataflow pipeline involves A. Efficient transform design, minimizing the use of resource-intensive transforms. and combining operations where possible to reduce overhead. B. Autoscaling configuration. Properly configuring autoscaling options to ensure resources are dynamically adjusted based on workload. C. Resource allocation. Choosing appropriate machine types and instance sizes to balance cost and performance. D. Data shuffling optimization. Reducing the amount of data shuffled between workers by using combiner functions and efficient partitioning strategies. E. Monitoring and tuning. Continuously monitoring resource usage and making adjustments based on performance metrics and observed workloads. These optimization strategies help reduce costs and improve the efficiency of the pipeline. 39. What is the role of the Apache Beam SDK in Google Cloud Dataflow? Answer. The Apache Beam SDK provides the programming model for defining data processing pipelines that can run on multiple execution engines, including Google Cloud Dataflow. It offers a unified API for both batch and stream processing, allowing developers to write portable and reusable pipelines. The SDK includes a variety of built-in transforms, IO connectors, and utilities to simplify pipeline development. In the context of Google Cloud Dataflow, the Beam SDK serves as the interface for defining and executing data processing logic, with Dataflow providing the underlying managed execution environment. 40. How do you handle real-time analytics in Dataflow? Answer. Handling real-time analytics in Dataflow involves A. Streaming source integration, reading data from real-time sources like pub or sub or Kafka. B. Windowing and triggers, using windowing and triggers to aggregate and process data within specific timeframes, ensuring timely results. C. Low latency processing, designing pipelines to minimize latency and ensure rapid processing and output of analytics results. D. Real-time dashboards, integrating with visualization tools like Data Studio or custom dashboards to display real-time analytics. E. Alerts and notifications, implementing alerting mechanisms to notify stakeholders of significant events or anomalies detected in real-time data. These techniques enable real-time data processing and analytics, providing timely insights and decision-making capabilities. 42. How does Dataflow integrate with BigQuery? Answer. Dataflow integrates with BigQuery through built-in connectors, enabling seamless data movement between the two services. Common integration patterns include A. Reading from BigQuery, using the BigQuery I/O connector to read data from BigQuery tables into a Dataflow pipeline for processing. B. Writing to BigQuery, using the BigQuery I/O connector to write processed data from a Dataflow pipeline to BigQuery tables for storage and analysis. C. Batch and streaming support, supporting both batch and streaming data integration, with BigQuery enabling real-time and batch data analytics. This integration allows for efficient and scalable data processing and analysis workflows. 43. What are the security best practices for Dataflow pipelines? Answer. Security best practices for Dataflow pipelines include A. Data encryption, ensuring that data is encrypted both in transit and at rest using Google Cloud's encryption mechanisms. B. Access controls, implementing fine-grained access controls, using IAM roles and permissions to restrict access to Dataflow resources and data. C. Network security, using VPC service controls and private IPs to secure network communications and isolate Dataflow jobs within a VPC. D. Audit logging, enabling cloud audit logs to monitor and log access and actions taken within Dataflow pipelines for compliance and auditing purposes. E. Secret management, using services like Secret Manager to securely manage and access sensitive information such as API keys and passwords. These practices help secure Dataflow pipelines and protect sensitive data. 44. Explain the role of pub or sub in a streaming data flow pipeline. Answer. Pub sub serves as a messaging and data ingestion service in a streaming data flow pipeline. It acts as an intermediary that captures and delivers streaming data to the data flow pipeline. The role of pub or sub includes A. Data ingestion, collecting data from various sources, such as IoT devices, application logs, and user interactions, and delivering it to the data flow pipeline for processing. B. Decoupling, decoupling the data producers and consumers, allowing them to operate independently and scale separately. C. Reliable delivery, ensuring reliable and durable delivery of messages with at least once or exactly once delivery semantics. D. Scalability, handling high throughput and scaling automatically to accommodate varying data volumes. Pub or sub enables real-time data streaming and processing in data flow pipelines, supporting various real-time analytics and event-driven applications. 45. How do you manage schema changes in Dataflow? Answer. Managing schema changes in Dataflow involves A. Schema versioning, implementing versioning for schemas to track and manage changes over time. B. Backward and forward compatibility, designing schemas to be backward and forward compatible, allowing old and new versions to coexist. C. Data validation, implementing validation logic to check for schema conformity and handle discrepancies gracefully. D. Schema evolution, using tools and frameworks that support schema evolution, such as Apache Avro or protocol buffers, to manage changes without disrupting the pipeline. E. Testing, thoroughly testing schema changes in a staging environment before deploying to production to ensure compatibility and correctness. These strategies help manage schema changes smoothly and ensure consistent data processing. 46. How does Dataflow handle late data in streaming pipelines? Answer. Google Cloud Dataflow manages late data in streaming pipelines using windowing and triggers. Late data is data that arrives after the window for its event time has closed. Dataflow allows configuring the window to stay open for a certain period to accommodate late data, using a concept called allowed lateness. Triggers can also be set to specify when results are emitted, which can be based on event time, processing time, or a combination of both. For handling late data, Dataflow provides options like watermarking, which tracks the progress of event time, and triggers to ray fire when late data arrives, ensuring that the pipeline processes all relevant data while maintaining accurate and timely results. 47. What are side inputs in Dataflow and how are they used? Answer. Side inputs in Google Cloud Dataflow are a mechanism for providing additional datasets that are small enough to fit in memory and can be used alongside the main input data in a pipeline. They are particularly useful when you need to join a large dataset like the main input with a smaller reference dataset like the side input without performing a costly shuffle operation. Side inputs can be accessed by each worker processing the main input, allowing operations like enriching or filtering data based on the side input values. They are typically implemented using the as singleton, as iterable, or as list transforms in Apache Beam. Side inputs help enhance the flexibility and functionality of Dataflow pipelines by enabling complex data transformations and lookups efficiently. 48. How can you optimize data shuffling in a Dataflow pipeline? Answer. Optimizing data shuffling in a Dataflow pipeline is crucial for performance, as shuffling involves redistributing data across different workers, which can be resource-intensive. Strategies for optimization include using combiners to perform partial aggregation before the shuffle step, thereby reducing the amount of data that needs to be transferred. Another technique is to carefully design partition keys to ensure even distribution of data, avoiding skew and hotspots. Additionally, using windowing and grouping operations effectively can help manage the data distribution more efficiently. Monitoring and analyzing the shuffle operations using Dataflow's monitoring tools can also provide insights into performance bottlenecks, allowing for further tuning and optimization. 49. What are the key features of Google Cloud Dataflow's monitoring tools? Answer: Google Cloud Dataflow offers robust monitoring tools that provide comprehensive insights into the performance and health of data pipelines. Key features include real-time visual dashboards that display job status, execution graphs, and detailed metrics on data throughput, latency, and worker utilization. Stackdriver monitoring and logging integration allows users to set up custom alerts, track logs, and analyze performance trends over time. These tools help in identifying bottlenecks, diagnosing issues, and optimizing resource usage. Additionally, Dataflow's monitoring tools support detailed job metadata and worker-level statistics, enabling fine-grained analysis and troubleshooting of pipeline execution. 50. How does Google Cloud Dataflow integrate with Apache Kafka? Answer: Google Cloud Dataflow integrates with Apache Kafka through Apache Beam's Kafka.io connector, enabling seamless ingestion and processing of Kafka streams. This integration allows Dataflow pipelines to consume data from Kafka topics in real time, process it using various transformations, and then output the results to different destinations, such as BigQuery, cloud storage, or another Kafka topic. The Kafka.io connector supports both batch and streaming modes, providing flexibility for different use cases. Configuring the Kafka connector involves specifying Kafka brokers, topics, and additional consumer properties. This integration facilitates building scalable, real-time data processing applications that leverage Kafka's robust messaging capabilities alongside Dataflow's powerful processing framework. The above 50 questions and answers provide a comprehensive overview of Google Cloud Dataflow, a fully managed service for real-time and batch data processing. They cover essential concepts such as the Dataflow programming model, pipeline architecture, windowing strategies, and the handling of late data. The questions and answers also delve into advanced topics like stateful processing, fault tolerance, and optimization techniques. Additionally, they address practical aspects, including integration with other Google Cloud services, managing schema changes, and using monitoring tools for performance tracking. These insights collectively equip users with the knowledge needed to design, implement, and maintain efficient and reliable data processing pipelines using Google Cloud Dataflow. For more exciting tips, tricks, and more importantly, for valuable insights of interviews, please share, like, and subscribe to my channel. It has a lot of valuable information about various insights of interviews. It has a wide range of real-world portfolio projects of various technologies for interviews, and it has wide range of most asked interview questions and answers of various technologies like data science, SAP, AWS, DevOps, and full-stack web development, and more, that will be useful during interviews. It has a wide range of most asked interview questions and answers and real-world portfolio projects of various technologies for freshers, for 2 to 3 years, experienced candidates, and for 5 or above years, experienced candidates to test their skills by knowing most asked interview questions and make themselves ready for interviews.